All right, in lesson number 1, question number 5, it asks, can every vector in the xy plane be written as a linear combination of u and v? And it asks you to justify your answer. So basically, here we go back to that piece of paper analogy. So if I have a piece of paper, the question is, a linear combination is, can I get from point A to point B with the vectors given? If I have two vectors that are facing these directions, I can rearrange them to get me there. So I could use small factor of u, so AU, and then I'll just spread out, make that B or V vector very, very long, and it gets me there. When we run into trouble, real possibilities, I suppose, is when those vectors, u and v, are facing the same direction. So if they're parallel. So if they're parallel, that means that I can only move from point A. I can move right, or I can move left. I can never, ever move on an angle and get there. So basically for question A, it's just saying, are these two vectors parallel or collinear? So we do our check here. So u equals the vector 1, 4. It's already got a 1 to begin with. Vector v, I'm going to check. Negative 2, 5, and you're already saying, no, it's not, and I agree, but I'll do it anyway. Negative 5 over 2. So therefore, not parallel. All right, so that means that we can use them to get from point A to B. We don't want them to be parallel. So question B wants us to find the linear combination to get us there. So that means that my final answer that I want, I don't know why they have to pick such big numbers, but negative 5, 6, 7, negative 6, 6, 9, we need to use u and v to get there. So that means I'm going to need some multiple of u. So a times the vector u, plus I'm going to need some multiple of v to get that final vector. So now this is when grade 10 math kicks in for you. So I know that negative 567 equals 1a minus 2b. I know that 669, the y components, 4a plus 5b has to give me that answer. If you reach way back into the nether regions of the mind, this is two equations, two unknowns, so we're going to use elimination. So I'm going to multiply my top equation by 4. I'm going to leave my bottom equation alone. So that gives me even larger numbers to work with, which is always enjoyable. So negative 2, 2, 6, 8 equals 4a minus 8b. Negative 6, 6, 9 equals 4a plus 5b. I'm going to eliminate my a's. They have the same sign, so that means I have to perform subtraction. So I have to do subtraction in order to eliminate them. So that means it's going to be adding that 669 to my total. So I get negative 1,599. A's will disappear. And negative 8 take away 5. It's negative 13. We'll divide both sides by the negative 13. And we get an answer of positive 123. So that is the b value that's required here. And in my circular argument going around here, I'm going to go back to the original equation and do my substitution and solve for my a value. So I'm going to add that to both sides. Too lazy to punch that in. Do that all in one step. So negative 567 plus 2 times 123, which is just 246. And we got a equals, I believe, negative 321 if I punched it in properly. And there we go. So there is our answer. So in order to create that vector, that final vector they wanted, that means that we would have to get negative 567, I'll write this up, official, is equal to negative 321, 1, 4, so of the u vector, plus 123 of my v vector, which is 2, 5. So there we go. That is your final answer. That's what they are looking for you to do. So it's a bit of a flashback to grade 10 using that elimination process when you have two equations. If you have any further questions, let me know, and I'll try to clear them up for you.